Hi everybody, warm welcome. The topic for today's discussion is Linux file systems. Why learn Linux? Let me answer this question. Once you learn Linux operating system, you will get a clarity on how this operating system has been designed, how to work with Linux, what is the structure of Linux operating system, what are the main components, how to interact with the operating system, how to use the commands. So you will get a clarity on all these things, and this knowledge you can utilize efficiently in your current job profile as well as in future. It will help you to get better job prospects. Linux is a widely used, most popular operating system. It is used in every environment. So it's very important to learn Linux for better understanding. I'm Sonal and I have got more than 25 years of IT experience. I have delivered more than 800 trainings for more than 180 clients across the globe on various technologies. My expertise is Linux, IBM AIX, Unix operating system, Bash shell scripting, ITIL, Amazon Web Services. Now, if you're planning to upgrade yourself, if you're planning to upskill yourself, you can choose Odin as a platform. Odin is a platform for upskilling technology. We help you continuously acquire new skills, so stay skilled, stay ahead. The agenda for today's discussion is understanding Linux standard files. What different files do we have and how these files are useful? Understanding file system structure, Linux hierarchical structure. Standard files. Now, once you log on, you are placed at a shell prompt and the operating system is ready to accept your request. You can start executing commands. You can type the commands using keyboard. You will get the output on terminal. You get the error message on a terminal. Now, how does this happen? What if I don't want to get the output on my terminal? Instead, I would like to send it to a printer. I would like to take a printout. Or I would like to send it to a different terminal. Or I would like to capture in a file. So how do I do that? So let us first understand the various standard files. We have three standard files: standard input, standard output, and standard error file. These files are opened as you log on to your Linux server. Now, once I get a login prompt, I am supposed to type my username and password. Once this information is provided, the authentication happens. And if we provide the correct username and password, we are authenticated by the operating system. And then the environment setting will be done by shell. And once all the environment setting is done, you are at a shell prompt. Now, before this happen, before you are placed at a shell prompt. These three files are there: input, output, and error. These files are opened for you. Now, what's the significance of these files? Standard input file takes the input from a standard input device, and the standard input device or the default input device is keyboard. So all the input coming from keyboard will be taken care by standard input file. The file name is stdin. Standard output file takes care of all the output which is supposed to get displayed on terminal. So the terminal is a standard output device. So any command you execute, default it gets displayed on the terminal, and that is taken care by standard output file stdout. When you type some incorrect command, you get the error message on terminal. So the default error device or the default file for displaying the error message is again a terminal. So terminal is used to display both the normal output as well as error output. So all the error message which is supposed to get displayed on terminal is taken care by standard error file stderr. Now we don't have to do anything. This gets open. All these three files gets open automatically in the login process and will get closed when you log out from your session. So all these three files are available to you for every command you execute at this prompt, shell prompt. If any one file gets corrupted, let's say my standard output file is corrupted, I won't get the output on terminal. Instead, I will get an error message. It will continuously give me an error message without displaying any command output. So these files are opened in the login, will be closed in the logoff. That happens automatically. We don't have to do anything for that. But what if I don't want the input from a keyboard, input from a standard input device? I don't want the output on a standard output device, that's terminal. And likewise error. So then how do I change the behavior of these three files? Now to change the behavior of all these three files, I will take help of redirection operator. We have got three redirection operator: less than sign, redirection input operator, greater than sign, redirection output operator. And we have got double greater than sign together, that's a redirection append operator. So by using these operators, I can change the default behavior of my standard input, output and error file. Now let's see the examples. How do I do that? Now let me first execute a command. So I am already logged on. I am at a shell prompt. Looking at this prompt, you can make out I am at a hash prompt. It means that I have logged on as super user, the root administrator. Now if I execute any command here, a simple command ls, I will get the output on terminal, and I am typing the command using keyboard. So I am using standard input device for typing the command. Standard output device is used to display the command output. If I type some incorrect command, let's say I am giving some, here I gave XYZ which is a non-existing file, it's giving some error message which is again getting displayed on terminal. So I'm basically using the standard files here. Now I don't want the input from a keyboard. Let me use an example. Let's say cat. If I just use a cat without any argument, it is an interactive command. It's just waiting for the input, not giving me the shell prompt. I type something, I hit enter, and that gets displayed on terminal. So this is an example of using a standard input and output file. But I don't want the output to be displayed on terminal. I would like the output to be captured in a file. So if I want to change the default behavior of standard output file, I will have to take help of standard output operator. If I want to change the default behavior of standard input file, I will have to take help of redirection input operator, which is less than sign. So for input I use less than sign, for output I use greater than sign. And for error, again it is greater than sign, but we need to differentiate between an output and an error. So I use 2 greater than sign. Now what are these numbers? 0, 1, 2. These are file descriptors. A file descriptor is a identifier given to these three files. It's same standard across all Unix and Linux platform. So 0 is reserved for input file, 1 for output, 2 for error. Now so what I need to do, I will have to prefix the operator with its file descriptor. I can use 0 less than sign, 1 greater than sign, and then 2 greater than. But for input and output, it is optional. You can just use less than sign or you can use a file descriptor. Now let me use this in my command. So presently my requirement is I would like to keep the output. Now when I'm just giving a cat type, giving some input through keyboard, it is getting displayed or sending the same data to the standard output file because it does not know in which file it should store. I did not provide any file name. So what I type, it goes to the terminal. Now I would like to store this in a file. So means what output getting displayed on terminal, I would like to keep it in a file. It means I would want to change the default behavior of standard output file. And for changing the default behavior of output file, we have got greater than sign. I provide some file name after greater than sign. Let's say my file name is new file. Now whatever I type, that instead of getting displayed on terminal or instead of using a standard output file, it is getting redirected to a different file. So in this command, I change the default behavior of stdout file. Let us check. Yes, the content is there in a file. Let's see how do I change the default behavior of input file. I need to use less than sign. Now I do not want the data. Now in this command, I was inputting the data through keyboard. But now I don't want to input the data through keyboard. So what I'm doing, cat less than sign a file name. Now what it is going to do, the content of new file put it to cat command and then hence it gets displayed on terminal. So instead of taking the input through keyboard, it is taking it from a file since I used redirection input operator. It's getting displayed on terminal. One more example, I am using a wc command. Basically, wc command is used for a word count. I would like to do a word count of this file. So I am using wc and a file name. It provides me first data is number of lines in a file, number of words, and then finally number of characters. So 2 lines, 2 words and 9 characters I have in my file. To understand it in a better way, I can utilize the options. wc-l, L is for lines, to get the line count. We have got W option for word count, and we can use C option to get only character count. Okay, now I can use this redirection operator. Now WC, I use redirection input operator and then I provide a file name. It takes the input from a file and provides me the word count. Or WC file name, whatever it is displaying on terminal I would like to capture in a file. So redirect greater than sign output operator and providing some file name. Let's say my file name is output. And then I do cat for this output file. I get to see the content. So this is how I take the input. If I just use a WC, again it's an interactive. Whatever I type here, it will provide me the word count of that the moment I come out of this. I am giving Control D to come out of, and it provides me word count. But when I do WC input operator and a file name, it does the word count of the content from a file. Now the next redirection operator is to greater than sign. What if I would like to capture the error message in a file? Now here I just provide a command, let's say cat of xyz, which is a non-existing file. I am getting an error message on terminal which I would like to capture in a file. I do greater than sign and I specify the file name. Let's say my file name is err file. Now let's see what happens when we don't provide the file descriptor. I am not giving the file descriptor 2 here. Okay. I just give greater than sign. Let's see if it gets redirected. It doesn't. Because greater than sign is used as a redirection output operator. So as I said, we need to differentiate between output and error. So whenever I would want to redirect the error message, I will have to use 2 greater than sign. And hence it gets redirected. Let us quickly check, because we can easily make out if nothing is getting displayed on terminal, it means everything has been redirected to a file. Let me cross check. I do cat for err file. I can see the same error message xyz, no such file or directory. If I want to append the error message, let's say cat of abc. Again the error. I would like to append this error message in the same file, err file. So I can use the append operator with the error. So to double greater than sign, it appends the error message in a file. You can even use this append operator while you use, use any other command. So this is how we change the default behavior of standard input, output and error file. Now let me use all these three together in a file, together in one single command, all these three redirection operator. I will quickly create a small script for that. Just putting some commands in the script. Okay, this is a small script and this is the execution of a script. Now just I have added some a command which should give me a normal output, and let me just add. I am adding a command that should not give me, that should generate some error message. Okay, done. sh, I am executing this script, sh of demo, and I can see a normal, means I can see a mixed output, a normal and a error. First two lines a normal output because the command syntax was correct. The last one I just made some syntax error, so I'm getting an error message here. So basically when I'm executing this script, I'm getting a mixed output on my terminal. I would like to capture this complete output in a file. That is one requirement. Another requirement, I would like to filter or segregate the normal output in one file and error message I would like to keep it in another file. So let's see how we can do both the things. So I am using greater than sign for a normal redirection. I specify my file name as output and two greater than sign for error. So whatever now this script, once it is executed, the normal output goes to output file, the error message goes to ERR file. Let's check cat of output file. Yes, I have the normal output in that file. Let me do cat of ERR file, and yes, the error message has been redirected to this file. Or now if I want to use all the three redirection operator. Now cat, I use less than sign, which is a input operator. I provide this file name. I use a greater than sign for normal output. I use two greater than sign for error file. So this is an example where I am using all the three operators together. This file is opened by shell. The entire content will be given to cat command. Cat will send the normal output to this file and it will redirect the error to this file. Okay, now in this command, I use two different files, each for holding a normal output and a error. What if I would like to capture everything in one single file? I don't want two different files. So if I am using cat or sh, I use my script name and then I just go with greater than sign a file name. So this will just capture the normal output. The error will be sent to terminal. Or if I use two greater than sign, the error goes in a file and normal comes on a terminal, right? So now how do I capture both? I do sh my script name I use a normal greater than sign. I specify the file name where I would like to capture the complete output, and then I am using association operator, which is 2 greater than ampersand 1. This is known as association operator. It associates the functionality of standard output and error message. Now, as I hit enter, the complete output has been captured in the output file. Let me do cat of output file, and yes. So this is how I can capture everything in one single file. Now let us understand what is file system. File system is a very important part of Linux operating system. It is an important part of all the Unix based operating system. The entire operating system is there stored as a hierarchical file system. Without a file system, you cannot work with the operating system. So it's the most important part of operating system. Now what is a file system? A file system is a collection of files and directories. A file system is an organized way of arranging files and directories in a hierarchical file system structure. How files and directories should be placed in a structure, in a hierarchical structure that is being defined in a file system. So it's a method of organizing the on the storage media. Now when you install Linux operating system on any hard disk, how it should keep the data on a hard disk, where it should keep the data, where to keep which data, how to segregate the system files and user files. So all that is being defined in a file system, and accordingly it will be stored. So it's a method of organizing the data on the storage media. So once the operating system is installed, you will get a hierarchical file system structure, which is upside down tree. As you create any file or a directory or you install any device, everything will be connected to this structure, hierarchical structure, or everything has to be connected to this structure for a user to be used, for a user to be accessed. You create a new file system, a new partition, even that will be part of the tree structure. So everything, all the files and directories, all the devices, everything is maintained as a single tree in the Linux operating system, and that's a file system. Now when you are creating a new file system, you will have to mount it to be accessed. When you are attaching a storage device, for example, you are connecting a pen drive, or you want to access a CD-ROM drive, or you want to utilize a newly created partition. So you will have to mount it on an empty directory, only then you can start using it. Mounting is a process of attaching a file system to the tree structure. Now what is the tree structure? This is the structure. This is a hierarchical file system structure. Now when you are mounting, for example, I am mounting a TMP. So this gets connected to the tree structure. Or I'm mounting some new file system, or I'm mounting some device. So I create a new directory somewhere. Under this structure, I am supposed to create a new directory, and then that will become my mount point. So once I mount, this gets connected to the existing tree structure. So mounting is a process of attaching a file system to the existing tree structure. If I want to remove this, or removing in the sense, I would like to detach it from the tree structure, I will have to unmount it. So unmounting is a process of detaching from the tree structure. The moment you unmount, this will get detached. It is just detaching, not deleting or not removing the content present here on this file system. So the content will be intact, only the attachment is removed, and since there is no connection between this file system and the tree structure, you won't be able to access the content. Once you mount it, you can access it. So every file system to be accessed has to be mounted. Now let us understand this hierarchical file system structure. There are some standard components, standard file systems, as well as system directories. Now we have got the most important file system is root file system, indicated just by a forward slash. Next important as well as a standard file system of all the Linux based operating system is tmp, var, usr, home. We have one more known as opt. So root, usr, temp, home, opt, var. These are the standard file systems of all the Unix based operating system. All these file systems are required for the functionality of the operating system. If any of the file system gets corrupted, your operating system will not behave properly. So out of all these, what are the mandatory file systems? Let me highlight. Root is the mandatory file system. It is required to be always in consistent state. Root. Next is tmp, var, and usr. These are the four file systems which are required to be in consistent state. If any of these four file system gets corrupted, you will not be able to work with the Linux operating system. Your OS goes down. Now what is there in these file systems? Root is the topmost object of the tree structure and everything is under root. Home is a file system which is a default home directory for all the regular users. You create any user in Linux, default it will be created under home. Let me quickly provide you a demonstration here. I am already logged in as a root, so I have the rights to create a user. I am just using a user add command and I just create a simple user. I am not providing any user like any options. I don't want to customize. So let's say my username is Odin and it's created. Now let's see where the home directory of this user has been created. So as I said, the default home directory is /home. So you can see the home directory of user is under home Odin. If I switch to this user Odin, I am automatically placed under that user's home directory. So home is the default home directory for regular user. Now if I log on as a super user, that is root, my default home directory is this one. Let me show you quickly. I am there as a root right now. If I do pwd, you can see I am there under /root. So this is a home directory of root. Now what basically home directory is? Home directory is a place where you are placed the moment you log on, and whatever you create a file, you create a directory, you are there, it gets created under your home directory, inside your home directory. So it's a place where you have a control to work, to create. Next is TMP, short form of temporary. So all the temporary files are there under TMP. When you download something, some temporary files gets downloaded, so that also will get stored under TMP. When you are migrating files from one system to another system, some temporary files get created. So it's a file system. TMP is a file system which holds temporary files. var. Var file system is used to hold varying nature files, all the variable files, the files of which the data keep on changing. For example, log files. You will find all the log files are present here, whether it's a startup log, that we call it as a boot log, error log, system log, application logs. So you will find the logs are here, and log files data keeps on changing. Cron files. If you have scheduled some job, so the files will be kept under var. Mail files. All the incoming mails will be stored in a file, so that you will find under var. So basically all varying nature files are there under var. Next is USR, Unix System Resources. USR. USR it holds the files which the binaries, the libraries, the shared applications which can be used by the regular user. So USR holds user binaries, user libraries, shared applications. OPT, optional software. When you install some additional package or an application, that default it gets stored under OPT. You can customize, but default location is OPT. So root, USR, var, temp, home, OPT. These are the standard file systems of Linux. All these file systems you can have it in a separate partition. Now apart from this, in a hierarchical file system structure, you will find lot of other system directories are there. For example, bin, dev, boot, etc. All these are system directories. So all these system directories or file systems basically hold group of related files. Now what is bin? Bin is a short form of binary. So all the binary files, the executable files are there. You will find commands are there, command files are there stored under bin. Dev, short form of device. All the device files are created present under dev. Boot, bootable files. The files which are required to boot the operating system. So the kernel file is also there under boot. etc. It's a directory which holds system files or the configuration files. Security files. The files which are required for securing. Configuration files, when you want to configure some service on Linux, the files are present under etc. Let me quickly show you this. Now, as I said, security files are there. Now, when I create some user or when the user authentication happens, basically two important files are there which will be used for holding the user information as well as for authenticating the user, and those files are present under etc. The file name is passwd. etc passwd. You can see here this holds the user information, the user which I created just now, Odin user. So this user information is present in this file. I have another user by the name Linux. If I go up, the very first user I can see here root. So it is a file that holds the user information and it is present under etc. Likewise, we have another file known as shadow. This holds the password. Shadow file is used to keep the password of the users. So you can see this file is also present under etc. So likewise, we have so many other important files under etc. Lib. Lib is a short form of library. All the library files are stored under lib. Libraries are required by kernel as well as required for application. Next is proc. Proc is a short form of process. Proc holds, it's actually a memory based file system and it holds all the running process information. Whatever process are running, the OS as well as the user process, that information will be kept under proc, and it's a memory based file system. So it does not occupy any space on your hard disk. Sbin. System binaries. All the operating system administrative commands are stored under sbin. The commands which can be accessed, executed only by the system administrator are there in sbin, system binaries. MNT. MNT is a default directory used as a mount point. It's a default mount point. When you are attaching some storage device, a CD-ROM drive, a pen drive, or suppose you have created a new file system and you would want to mount. So instead of creating a new directory, you can mount to this location MNT. Lost plus found. This is a directory which gets created when you create a file system. As you create any new file system, lost plus found will be automatically created in that. And not just for a new file system, lost plus found you will find in every file system. The importance of this directory is it is used to keep any unreferenced file. If your file system is corrupted, you are supposed to check the file system. You are supposed to scan it by using a tool, FSCK, file system checking. So when you are doing FSCK for your corrupted file system, if it come across the FSCK program, if it come across any unreferenced file, it will send that file or it will store the file in a lost plus found directory. So these are the standard components, standard file systems, as well as system directories present in a hierarchical file system structure. These are the file systems and the system directories which are present on the local drive, on the local hard disk. When you do the installation of the operating system, this structure will be created on your hard disk. But suppose if you want, you can also mount a remote file system. You can also mount a drive. Windows has got drives. So if you want, you can mount a Windows drive on a Linux, in a Linux operating system, and once you mount it, even that becomes part of this existing tree structure, because you are mounting on an empty directory and the directory that you create will be present in this structure. So you can mount a Windows drive, you can mount a remote file system using an NFS. So even the NFS also, you after you mount using NFS, the mount point will be again present in this structure. So whether you mount a local file system or a remote file system, ultimately everything has to be present and will be present in this hierarchical file system structure. Now suppose if I want to access any file or a directory in this structure. If I go back, I would like to access this structure. I would like to access a file. Let's say I would want to access a file which is created under home by some user. Now there are two ways. Either we can use the absolute path name, means giving a complete address of a file, or we can use a relative path name. Absolute path name always starts with /, the topmost object of the structure, hierarchical file system structure. So let's say under home, I have just now created Odin, which is a user, and this user has created one file by the name XYZ, and I would want to access this file. Now by using absolute path, what I am going to do? I will use /. This is my root, and then I will go to home, the next level. Again under home I have Odin, the next level, and then again one more level down under Odin I have got XYZ file. So this is known as absolute path. Any path that starts with a / is a absolute path. Now if I am already there under Odin, my current directory is Odin, I can directly access this file by using a relative path. So these are the two ways to access a file from the file or a directory or any object from the hierarchical file system structure. Quick example of this. Now here itself you can see I gave for first /, which is my root, and then inside that I have etc directory. Inside etc I have got a shadow file. So this is the absolute path, though I was not present, like I am there in a different directory. So I can access any file and directory providing the complete path. If I change to etc, let me get into etc. Now I can directly do a shadow, cat of the shadow. This is a relative path. Okay. Now let's see how do we do mounting. As I said, mounting is a process of attaching a file system to the existing tree structure, and unmounting is a detaching it. Let me give you an example. I have got a newly created partition and a file system on that. So this is my newly created partition xvdf1, and I have already formatted it. A file system is created. Now I just have to mount it. But before I do that, I will execute a command to check if it is already mounted. Df command is used to get list of all the file systems and the utilization. How many file systems are currently mounted and the utilization of that file system. How much free space do I have in the file system and how much of a use space. So you can make out. Now in this I can't see this newly created file system. Let me mount. So before I go for mounting, I will create a directory. I will create a new directory. So mkdir, now it's up to me where I would like to create a new directory. I have the access to hierarchical file system structure. Let me create it under root. Let's say by the name new fs. Now let me mount. The syntax is first you will have to provide the device to be mounted. Now my device name is this one. So slash dev slash xvdf1 and then mount point where I want to mount. So my mount point is new fs. Done. Let me check df. Yes, it is mounted. Now if I do ls for this, it's ready for use and you can see lost plus found directory is there. So when you get to see lost plus found, that indicates that it's a file system. It's not just a normal directory. Even I can use mount command also to get the list of all the mounted file system. So new fs is mounted. Now how do I unmount it? The command is umount and specify the mount point. It's unmounted. I run df command and I don't get to see that. So it is unmounted. Now when I do ls of this, it's just a normal directory. I created this directory before I mounted my file system. So this is just a directory. Now you can't see the lost plus found directory over here because it is just a directory. It is not pointing to a device or it is not acting as a file system. Once I mount it back, I get to see the lost plus found because now it is a file system. So that is how we work with a file system. If you want to see the existing tree structure, you just do ls of /. So these were the objects that we discussed. tmp, var, usr, sbin, system binary, proc file system, root home directory of super user, mnt the default mount point, opt the optional package optional software, bin for binary, boot for bootable files, etc configuration file, device file dev, lib libraries. So all the standard file systems and system directories are present here in this location under /. As long as your operating system is up and running, you cannot unmount the standard file systems. Especially, you cannot unmount the root, TMP, var and USR. This cannot be unmounted when you are already logged in, because those are the file systems which are used, which are engaged. So the engaged file systems cannot be unmounted. So that's all for today. A quick recap. Today we discuss what are the standard files. The three standard files: standard input, output and error file. And how do we change the default behavior of those files using redirection: input operator less than sign, output operator greater than sign and error 2 greater than sign. The file descriptor 0, 1, 2 which is being given to these standard file, and how when these files are open and when the files are closed. Then we discuss about Linux hierarchical file system structure. A file system is the most important part of all the Linux as well as Unix operating system. So it is required to have a clear understanding of file system. You Without having a proper understanding of file system, it's very difficult to work with the operating system. So we discuss what are the standard file systems, what type of files are kept in those standard file system directories, and the importance of file system directories. We define what is a file system, how to mount, unmount. So that's all for today. If you like this video, please don't forget to like and subscribe. Hope you enjoyed the session. Hope you found the session helpful, useful, insightful. Thank you so much. Thanks all for joining me. Bye bye.